In this video, I'm going to show you how to add and subtract rational expressions that have a non-monomial denominator, meaning that the denominator will be a binomial or maybe even a trinomial. So no matter what type of question it is, we should always try to factor the denominator so that we can find the lowest common denominator. So in this first expression, we have a 2m in the numerator, and then the denominator, I can factor out a 3 to get m minus 5. In the second fraction, I can factor out a 6 to get m minus 2. Now, we want to factor to find the lowest common denominator because sometimes if we don't factor, you're going to get something really, really big in the denominator, and then you'll get something that's really hard to simplify. So I'll show you some other examples later on. So I'm going to find the LCD. And remember, we go to the first fraction with the first denominator, and I have a 3 and an m minus 5. I go to my second fraction, and I have a 6 and an m minus 2. Now, I don't actually have to write 6 because I can see that I already have a 3 here, and 3 is a factor of 6. So to obtain 6 for my LCD, I really only need an extra 2. So I'm actually going to squeeze in a 2 in here now. So I have 2 times 3 times m minus 5, because the 2 times 3 gives me the 6. And I also now need an m minus 2. So this is my LCD. Notice that everything is being multiplied together, and I'll even exaggerate that by separating it with dots or time symbols. Now, the numerator I don't have to worry about. I don't have to actually factor the numerator because it's the denominators that I need to factor so I can find the lowest common denominator to join these two rational expressions together. All right, so when I take a look at the first rational expression, the first fraction, I can see that I am missing a 2. So I need to multiply the top and bottom by 2. And I check back my LCD. I'm also missing an m minus 2. So I'm also going to put an m minus 2 over here and an m minus 2 right there. I go to my second fraction, and I need a 6. So I have the 6 already, m minus 2. I am missing an m minus 5. So I'm going to multiply that by the top and the bottom to get an equivalent fraction. So remember, whatever we do to the top, we must do it to the bottom. Now I'm going to distribute my numerator and expand it. So here I have 4m. So 4m times m is 4m squared. And then 4m times negative 2 is negative 8m. In my second fraction, now be really careful, I have a minus here, and this minus here in the middle actually belongs to the negative m. So I have negative m times m. That would be negative m squared. And then negative m times negative 5 is going to be positive 5m. So be careful of the negative because you must distribute it in the entire second fraction. The denominator, since it's the same in both fractions, I'm going to write this as 6 bracket m minus 5 times m minus 2. Simplifying the numerator by combining my like terms, I get 3m squared minus 3m. And I rewrite my denominator. Now, actually, in my numerator, I can see that I can factor out something. So they both have a 3 and the m in common. So I'm going to factor out 3m. And then I have m minus 1 left. Remember, when we factor, we are dividing. So 3m doesn't become 0, but remember, it's 3m divided by 3m, which gives you 1. So always multiply it back out to check if you're not so good at factoring. So you can see if you get the expression that you had before. All right, so I can check now, and I find that I can't reduce. Now, the purpose of factoring was to see if I can cancel anything off with the denominator, but in this case, I can't. So finally, I need to find my non-permissible values, and I'm going to go back to my original question. Oh, and actually, it's not x, because my expressions here, the variables are m. So I have 2 variables in the denominator with the factors. So I have an m minus 2, so m cannot equal 2. I have an m minus 5 in the denominator, so m cannot equal 5 as well. And that's it for this first one. All right, let's take a look at the second question. And I can see, again, that in my denominator I can factor, and this is a difference of squares. So we get p minus 1 times p plus 1. I'm going to find my lowest common denominator. I go to my first fraction, and I see that I have a p minus 1 and a p plus 1. I go to my second fraction, and I see that I have a p plus 1, but I already wrote that down in my LCD, so I don't need to write it again. Okay, so I'm done finding my lowest common denominator. So my first fraction already has both denominators parts. My second fraction is missing a p minus 1. So I'm going to multiply p minus 1 in the numerator and the denominator. So now I have 4 plus, and this is positive, so that makes it nice, 3 times p, so 3p, 3 times negative 1 is negative 3. My denominator is p plus 1 and p minus 1. Simplifying my numerator, I get 3p, and then 4 minus 3 is plus 1. And then I have a p plus 1 and a p minus 1. Now some of you might be inclined to think, oh, I can cancel off the p plus 1 in the numerator and the denominator, but remember, we are joined by a plus sign. So unless this is identical, we cannot cancel anything off. So the numerator actually has, I'll put this in brackets to emphasize it, has a 3p plus 1 factor. So unless I see a 3p plus 1 in the denominator, I cannot just cancel the p plus 1 because the p is actually joined to the 3. Okay, finding my non-permissible values, we go back to the beginning, and we see that we have a p plus 1 and a p minus 1 from the first fraction. So p cannot equal 1 and negative 1. All right, to finish off, let's take a look at this last example here where we actually have a trinomial denominator. So like before, we need to factor. And remember, we only need to factor the denominator. So 9x squared minus 16 is a difference of squares. So we get 3x minus 4 times 3x plus 4. So let's extend this line to show that this is an entire fraction. Plus, and then we have 2x in the numerator. And the second one also factors, and we get a 3x minus 4. And then the second factor is going to be x. And then since we have a negative 4, we're going to have a plus 2. So this will be 3x squared, let's check. This will be 6x minus 4x in the middle, which gives me positive 2. Negative 4 times 2 is negative 8. All right, so let's find my LCD. So go to my first fraction. I have 3x minus 4, 3x plus 4. Go to my second fraction. I need a 3x minus 4. I've already written one down, so that's fine. And an x plus 2, which I don't have yet, so I need to include that as well. All right, so I have 3 factors for my LCD. When I go to my first fraction, I am missing an x plus 2. So I need to multiply the top and the bottom by x plus 2. In my second rational expression, I am missing a 3x plus 4. So I need to multiply the top again and the bottom by 3x plus 4. All right, so we're going to expand our numerator. So we get 3x times x, 3x squared, 3x times 2 plus 6x. And then here, remember, we have a positive sign that goes with the 2x. 2x times 3x is 6x squared. 2x times 4 is 8x. And all of this is divided by 3x minus 4, 3x plus 4, and an x plus 2. So simplifying my numerator, 3x squared plus 6x squared, I get 9x squared. 6x plus 8x, and I get 14x. All divided by this denominator, which has 3 factors. Now, I'm not going to actually bother factoring my numerator in this question because I know that the only thing I can factor is an x. So I'm going to be left with 9x plus 14, which I can see that won't cancel off with anything in the denominator. All right, so let's find our non-permissible values, and we're going to go back to the original question. So we have an x, 3x minus 4, a 3x plus 4, and then when I go to my second fraction, I also have an x plus 2. So those are the three factors we need to take a look at to find the non-permissible values. So the first one will be 4/3, and then 3x plus 4 can't equal 0. That means it's going to be negative 4/3. And the last one is x plus 2 can't equal 0, so we have negative 2. All right, so I've showed you how to add and subtract denominators that have a binomial or a trinomial expression.